Hello there, my lovely students. Hope you all are having a great Sunday because I am having an amazing Sunday myself. So, before I start this lesson, let me tell you that this video will be a little bit longer because we will be talking a lot of stuff in this video. So, as I always say, let's not make it complicated. Good afternoon out there, everyone. My name is teacher Prashant and I'm back with another video on linear graph, and in today's video we will learn something special. So in today's video we will learn how to find out the distance between two parallel lines on a graph, and by that we mean the perpendicular distance between two parallel lines on a graph, which means the closest, nearest or the shortest distance of two parallel lines, which we can also say that distance between two closest points of a set of parallel lines joined with help of a line segment. So the bottom line is we will be learning how to find out the closest distance between two parallel lines on a graph, just to make it simple. So let's find out what exactly we will be learning in this video today. So in this video we will learn how to find out the distance of two parallel lines on a graph, which are placed in three following ways. Number one is the parallel lines which are placed vertically on the graph. Number two is the parallel lines which are placed horizontally on the graph. Number three are parallel lines which are placed slanted or sloped on the graph. So number one, number two, and number three. This is exactly what we will be doing in our lesson today. So let's get started with our lesson. Alright, it's time to find out the distance of two lines which are placed vertically on a graph. And in order to do so, we need two parallel lines on this graph which are placed vertically. So let's take an example of two lines AB and CD. Keep in mind that line AB is parallel to line CD. So question, how do we find out the distance between these two parallel lines on a graph? And answer is by finding out the perpendicular distance between them. Now what is the perpendicular distance between them? Perpendicular distance is the closest distance between them two lines, which are lines AB and CD. So in order to find out the closest distance between them, we have to join them two lines with help of a horizontal perpendicular line. Now what is a horizontal perpendicular line? Horizontal perpendicular line is a horizontal line which cuts this line AB and CD at 90-degree angle. So once we have our line, we can count the units, and those units will be the distance between these two parallel lines. Let's see how it goes. So let's join the line AB and CD with help of a horizontal perpendicular line, which is our line E and F. And we can tell that line EF is perpendicular to these two parallel lines AB and CD because line EF is actually intersecting both these parallel lines at 90-degree angle. That's how we can tell that line EF is actually a perpendicular line to the parallel line AB and CD. And this line also gives us a line segment joining these two parallel lines, and our line segment is E and F. So what is the length of the line segment EF? The length of line segment EF will be the perpendicular distance between these two parallel lines. So let's count the units. Unit 1, Unit 2, and Unit 3. So the distance between these two parallel lines is 3 units. And that's our answer. The perpendicular distance between line AB and line CD is 3 units. Simple as that. And the same concept is also applied to two parallel lines which are placed horizontally on the graph. But if in case our lines are horizontal or our parallel lines are horizontal, in order to find out the perpendicular distance between them, we have to join these two horizontal parallel lines with help of a vertical perpendicular line. It means we have to join these two lines with help of a straight vertical line which intersects these two lines AB and CD at 90-degree angle. So let's draw our line. So this is our line, and the name of line is E and F. So this line EF intersects the line AB and CD at 90-degree angle. And this line also gives us a line segment E and F. And the length of this line segment will be the perpendicular distance between these two parallel lines. So let's count. 1, 2, and 3. So the length of our line segment EF is 3 units, which is also the perpendicular distance between these two parallel lines AB and CD. So the perpendicular distance between line AB and CD is 3 units. Now, finally it is the time to find the distance of two parallel lines placed slanted or diagonally or sloped on a graph. And this is where life gets a little bit tougher, but if we follow 4 simple steps, we will be able to find out the exact perpendicular distance between these two parallel lines, which are line AB and line CD. So as we can see, line AB and CD are actually placed sloped on this graph. So how do we find out the perpendicular distance between these two lines, or the two closest points on these lines? So what is our step number 1? Our step number 1 is to find out the equation of a line AB and CD. And our step number 2 is to find out the equation of our perpendicular line. And once we have the equation of our perpendicular line, we can use that equation to graph our perpendicular line. And once we have our perpendicular line, we will use the distance formula or simple Pythagoras theorem to find out the perpendicular distance, and then we will be done with this lesson. So let's get started with step number 1. Now let's jump on to step number 1 and find out the equation of a line AB and CD, which are two parallel lines on a graph. Equation of a line of a straight line in linear graph is written in form of y equals mx plus c, which is also known as the slope-intercept form, where m stands for the value of gradient and c stands for the value of y-intercept. And in order to find out the equation of a line AB and CD, we have to plug in the value of m and the value of c into our equation of line, which is in slope-intercept form. So m stands for gradient, and the formula of gradient is change in y-coordinate divided by change in x-coordinate, which is also known as y2 minus y1 divided by x2 minus x1. So let's take any two coordinates on the line AB and use those coordinates to find out the value of m, or the value of gradient, for our line AB. So for example, I will choose these 2 points. Let's write down the x and y coordinate value. At this point, our x is minus 1 and our y is 2. And at this point, our x is minus 2 and our y is 0. So let's write down both of these coordinates right here. Minus 1 and 2 and minus 2 and 0. Now mark them as xy and xy. The first set of coordinate will be x1, y1, and the second set of coordinate will be x2, y2. Now plug in this value into the formula of gradient or slope and find out what is the value of gradient of line AB. So y2 minus y1 is 0 minus 2 divided by x2 minus x1 is minus 2 minus 1. So 0 minus 2 will give out the value of minus 2, and minus 2 minus minus 1 will give out the value of plus 1. So minus 2 divided by minus 2 plus 1 will be minus 1. So minus divided by minus will be plus, and 2 divided by 1 will be 2. So we got our gradient of line AB, which is 2. And we can also find out the gradient value for our line AB just by looking at the graph. So if you have a look at these two coordinates, the y difference between them is 2 units. Means between these 2 points, y is changing by 2 units. So change in y will be 2. And x is being changed by 1 unit, between these 2 points, so change in x will be 1 unit, which is change in y, which is 2, divided by change in x, which is 1, which will give out the gradient of m. And if you guys don't know what is gradient, what is y-intercept, what is equation of line, what is slope-intercept form, I have done a video on every topic, and I will put the link to all those videos on top of the screen so that you guys could click and learn more. And I highly recommend that you all should know the meaning of all these basic terms before you proceed yourself in solving advanced linear equations. Now let's come back to y-intercept. What is y-intercept? Y-intercept is a point where the line cuts y-axis on the graph. So our line AB is actually intersecting y-axis at this point. And at this point, the value of x is 0 and y is 4. Now y-intercept is also called as the value of y at a point where value of x is equal to 0. So since our line AB is intersecting y-axis at this point, where x is 0, y is 4, 4 will be the y-intercept of our line AB. So y-intercept will be 4. One more time, y-intercept is the value of y at a point where x is equal to 0. And y-intercept is also the point where a line cuts y-axis on the graph. So that's why 4 will be the y-intercept value of our line AB. So let's write down equation of a line AB. Y equals mx plus c. Our m value is 2. So let's plug in our m value. 2x. Our y-intercept is 4. So plus 4. And this will be the equation of line AB. So let's do the same thing and find out the equation of a line CD. But before that, keep in mind that two parallel lines have the same gradient. So the gradient of line CD will be 2 as well, because the line parallel to line CD is AB and AB has a gradient of 2. That's why CD will have gradient of 2, because two parallel lines have the same value for gradient. So the gradient of our line CD will be 2. What about y-intercept for our line CD? We don't have the point where the line intersects the y-axis. So how do we find out the y-intercept for line CD? It's very simple. Write down the equation of a line in slope-intercept form. Y equals mx plus c. And take any coordinate on the line CD. Let's take this coordinate where x is 4 and y is 2. Now we have the value for m, which is 2. We have the value of y, which is a y-coordinate, which is 2, and we also have a value of x, which is our x-coordinate, 4. So let's plug in the value of gradient and x and y coordinate, and we can find out the value of c by solving this equation for c. So 2 equals mx means m multiply x, where m is 2 and x is 4, plus c. So 2 is equal to 2 times 4 is 8 plus c. So in order to find out the value of c, you have to send this plus 8 on other side of equal to. Since on right hand side 8 is plus, when it goes on the left hand side, it will change its value from plus to minus. So c will be 2 minus 8. So our c will be minus 6. So we know that the y-intercept of our line CD is 6, and our gradient of line CD is 2, which is same as gradient of line AB, because two parallel lines have the same gradient. Now it's time to write down the equation of a line of CD. Y equals 2x means mx, and our value for m is 2. And our y-intercept value for line CD is minus 6. So plus minus 6 will give out minus 6. So our y-intercept will be minus 6. And we got the equation of a line for line CD, which is y equal 2x minus 6. And since these two lines have a same slope of 2 and 2, these two lines are considered parallel to each other. So our line AB and CD are parallel. And parallel lines have one common relationship, that two parallel lines have the same gradient value. Alright, let's move on to step number 2. So let's find out the equation of our perpendicular line really quick. So what is the perpendicular line in our case? Our perpendicular line will be a line which will be intersecting both our parallel lines ABCD at 90-degree angle. So how do we find out the equation of our perpendicular line? We do the exact same thing what we did when we found the equation for line AB and CD, which is write the equation of line in slope-intercept form, which is y is equal to mx plus c. So if you could find the value of m and value of c, we will have the equation of our perpendicular line. But the problem is, how do we find out the value of m, and where do we find out the value of c, which is value of gradient and value of y-intercept for our perpendicular line. But before that, let's focus on the gradient of line AB and line CD. So as we know that the gradient of line AB is 2 divided by 1, which is 2. And since CD is parallel to AB, line CD will have the same gradient, which is 2 divided by 1 is equal to 2. Now let's draw a perpendicular line which will intersect line AB and line CD. Keep in mind, this line is not to scale. This is just a random line drawn to explain you. So what is the slope of this perpendicular line which is perpendicular to line AB and CD? Why? Because this line is cutting AB and CD at 90-degree angle. So how do we find out the slope of this perpendicular line? Now this is where it gets a little bit complicated. It's time to learn the relationship between the slope of two perpendicular lines. The slope or gradient of two perpendicular lines is negative or opposite reciprocal of each other. So let's give a name to this line. So line GH is perpendicular to line AB and line CD, which are our parallel lines on this graph. So the relationship between the slope of two perpendicular lines is they are negative or opposite reciprocal of each other. So let's write down the slope of line AB. 2 over 1. We can also say it is plus 2 over 1. So if we have to find out the slope of this perpendicular line, we have to find out the negative reciprocal of the slope of line AB and line CD. Since line GH is the perpendicular line to line AB and CD, line GH will have a negative or opposite reciprocal slope of line AB and CD. So what will be the negative or opposite reciprocal of plus 2 over 1? Plus will change to minus, and 1 will become numerator and 2 will become denominator. So this is called the negative or opposite reciprocal of the slope of line AB or CD, and this will be the slope of our perpendicular line. So the slope of this line will be minus 1 over 2. So now we know the m value or the gradient of our perpendicular line GH, which is minus 1 over 2. So let me plug in the value of gradient, which is minus 1 over 2 x plus c. But we yet don't know what is the value of c, which is what is our y-intercept. Now this is where you have to pay real attention and you have to listen very, very carefully. We don't have to have a value for y-intercept for our perpendicular line. Why? Because our line AB and CD are infinitely long. There is no cap on the distance or how far these two lines will travel because lines have infinite distance. If these two lines have infinite distance, there will be infinite amount of perpendicular line intersecting these two parallel lines. Let's have a look. So our perpendicular line could be any line. We could use any one of these lines to find out our perpendicular distance between our line AB and CD, which are parallel lines on the graph. Now, do you realize that every perpendicular line will have a value of y-intercept? It means every perpendicular line will cut this y-axis on this graph at different location. Each one of these points will have a different value of y-intercept. But what is common between all these perpendicular lines joining our two parallel lines AB and CD? All these perpendicular lines will have a slope of minus 1 over 2. It doesn't matter what line we take, every line will have the same slope of minus 1 over 2. That's why we don't have to have a fixed value for y-intercept, because there are infinite amount of perpendicular lines we could have on this graph joining these two parallel lines. Now, since we know that our gradient value of all these perpendicular lines, which are perpendicular line to our parallel line AB and CD, have a slope of minus 1 over 2, which is actually the negative or opposite reciprocal of slope of line AB and CD. We don't need a value for y-intercept. And when I say we don't need a value of y-intercept, I mean that we don't need a fixed value for y-intercept, because at every point on y-axis where this perpendicular line will intersect y-axis will give out a different y-intercept value. So the y-intercept value will depend on which perpendicular line are we talking about. If we're talking about this line, then our y-intercept will be 4. If we are talking about this line, or if we are using this line to find out the perpendicular distance between these two parallel lines AB and CD, then y-intercept will be this point. If we are talking about this point, then 3 will be y-intercept. So what I want to say is, you don't have to look for a fixed value for y-intercept. You can take any value of y-intercept into our equation to map our perpendicular line. So if I take the y-intercept value of 4, this is the line I will end up with. And then if I find the distance of this line segment, I will find out the distance between these two parallel lines. So let me write down the equation of our perpendicular line, which is y is equal to minus 1 over 2x plus 4. Because I took this point as my y-intercept, that's why I took the c value of 4. So my y-intercept will be 4. So let me take different values of x as 1. Let me take x as 2. Let me take x as 3, and let me take x as 4. So let's graph our perpendicular line on our graph. So if the value of x is 1, what will be the y value of our perpendicular line? So y is equal to minus 1 over 2 times x. Our x value is 1. Plus 4, which is our y-intercept. So y will be minus 1 divided by 2 plus 4. So y will be minus 0.5 plus 4. So y will be 3.5. So when our x value is 1, y value is 3.5, and this is one of the coordinates of our perpendicular line. So let's go plot this coordinate. When x is 1, y is 3.5, which will be right here somewhere. So this is our coordinate where x is 1 and y is 3.5. So let's plug in the value of x is 2 and find out what is y, so that we get our second coordinate of our perpendicular line. So let's plug in x as 2. So y is equal to minus 1 over 2 times 2, because x is 2 in our second coordinate, plus 4. So y is equal to minus 2 over 2 plus 4. Minus 2 over 2 will be minus 1 plus 4. So y will be 3. So when x is 2, y is 3, and this is second coordinate of our perpendicular line. So when x is 2, y is 3. So this is our point. And at this point, x is 2 and y is 3. Now let's plug in our third x coordinate, which is 3, and find out the value of y. So y is equal to minus 1 over 2 times 3 plus 4. So y is equal to minus 3 divided by 2 plus 4. So y will be minus 1.5 plus 4. So y will be 2.5. So when x is 3, y is 2.5. So let's find our coordinate. X is 3 and y is 2.5. So it might be somewhere here. So at this coordinate, x is 3 and y is 2.5. Now let's plug in the last coordinate of x and find out the value of y. So y is equal to minus 1 over 2 times x is 4 plus 4. So y will be minus 4 divided by 2 plus 4. So y will be minus 2 plus 4. Y will be 2. So when x is 4, y is 2. So let's find our coordinate. Where x is 4, y is 2. So this is our coordinate. So when we join all these coordinates, we get our perpendicular line. So this is our perpendicular line, and if we find out the length of this line segment, we will find out the distance between these two parallel lines. So let's find out the length of this line segment EF and be done with our lesson. So to find out the distance between point E and F, we have a formula, and the formula for distance is under root y2 minus y1 squared plus x2 minus x1 squared. So let's form a triangle. So what is our change in x? Our change in x is 4. What is our change in y? Our change in y is 2. Change in x is 1 unit, 2 unit, 3 unit, 4 unit. Change in y is 1 unit and 2 unit. So we can plug in the value of change in y as 2. So 2 to the power 2 plus our change in x is 4. So 4 to the power 2. So let's solve this. 2 to the power 2 is 4 and 4 to the power 2 is 16. Now 4 plus 16 is 20. So what will be under root 20? So let's find out under root 20. So under root 20 will be 4.4721. So let's write 4.4721. So our length of this line segment will be 4.47 units. And 4.47 will be the PD, which means the perpendicular distance between this line AB and line CD. And we are done with this lesson. This is the longest video I've ever done in my life. Thank you so much for your patience, and thank you so much for watching. So once again, thank you so much for your time watching this long video. I hope you guys learned a lot today, and please consider subscribing if you are interested in learning maths content on my channel, and please do hit that bell icon so that you get notified whenever I upload a new lesson. So before I wrap up this video, let me tell you the topic for our next video. In our next video, we will learn why exactly the gradient and slope of two perpendicular lines are negative reciprocal of each other. So I will see you guys again very soon in my next video. Until then, take care. Bye bye.